Hi everyone. I'm going to go through this problem for the Kirchoffs rules. The one that I have online doesn't have any audio, so I'm going to use it through this program. With Kirchoffs rules, we have to use both the junction rule and the loop rule. I already have my junction rule written out, so I'm going to use I0, I1, and I2 as my current values. And the first thing we have to do with any Kirchoffs rules problem, or kirchoffs, I don't know how to pronounce that correctly, is identify the direction of the currents. Before we move ahead with that, you have to use these two rules if you have two batteries. If you only have one battery, you can probably just use the series and parallel resistor equations and kind of shrink down and expand the circuit. But with multiple batteries, you have to use these two rules. All right, so the first thing we have to do is identify or guess what direction the current's going to be flowing. All right, so I look at the battery right here, and I know that's the positive side, so that's going to push positives up through that wire. So I'm going to say that there's current that's going to be moving this way in that wire. I have a battery over here, and that's the positive side, so I'm going to say that the current is going to be moving that way as well. I'm going to call that one my I3. And then those two are going to come together and meet at this junction. So if I have current flowing this way and current flowing this way, it has to combine and flow down. Am I right? Actually, I'm not. I know I'm wrong already because I've already solved the problem. However, it doesn't matter if you guess correctly or not, and that'll be I2. All right, the next thing we have to do is write our loop rules. To do our loop rules, we have to decide a direction to move through the circuit. You're basically creating loops within the circuit. All right, so you want to try to have the motion through the circuit follow the current. So I'm going to make you have three options for loops. You have one loop, two loops, or the outer edge, three loops. All right, I'm going to use the two inner loops right here as for writing my loop rule. Okay. So I'm going to move in that area this way. When you go across a battery from negative to positive, you are gaining potential. All right? So basically, when we start off, we are going from a 0 potential here to a 12-volt potential there. So I'm going to gain 12 volts. And then I'm going to move through the wire. Nothing's going to interact with it. It's 12 volts, 12 volts, 12 volts. I come down this way, and then I use some of that voltage across that resistor. Now, when you're going through the circuit in the direction of the current, you are dropping down in potential. So you're kind of losing energy there. The resistor is going to dissipate that in the heat. And the amount of voltage that we're dropping is going to be equal to I times R, since that is Ohm's law, right? Ohm's law is V is equal to I times R. So the value of the current I2 times the value of the resistor 4. All right, so I'm going to include that here. So I'm going to subtract potential that is equal to I2 times 4 ohms. Put that right here. I have 4I2. Then I'm moving through again, and I have that current moving through that 3 ohm resistor. Now, how much current is in that 3 ohm? Between here and here, it's the same current, and it's going to be that I0. So I have minus 3 ohms times I0. And I'm back to the battery, so all of the 12 volts should have been used, and we end up with a sum of 0. Again, loop rule, sum of the potentials. Each of the potentials are the current times the resistance. Then we pick our other loop. I'm going to follow the battery and the current right here again. All right, so I go across the battery. I gain 5 volts. All right, nothing's happening between here and here until I cross that resistor right there. And that is going to be minus I2 times 4 again, so it's 4I2. You can see it's the same term in the previous one. Then I'm going back, and I'm going through the 2 ohm resistor, but the current through that 2 ohm is the same through the battery, so that's the I3. So I have 2 ohms times I3 equals 0. All right, this guy shouldn't have been there at any point in time. Thought I deleted that. So we have to write our junction rule. All right, the maximum amount of current, where is that going to be? Well, if we have current flowing this way to that point and current flowing that way to that point, those have to combine together and move down this way. So really, I0 plus I3 has to equal I2. All right, so there is my junction rule. All right, the next thing to do is to solve for one of the currents. It doesn't matter which one you solve for first, really. However, there's an easy way to go about combining these equations that lets you solve for basically the common factor in all three equations. So the one that's the same in all equations is we have I2 here, I2 here, and I2 here. All right, so we're going to solve for I2 first. What we want to do is take these equations and solve it for the thing we don't want. So we're going to solve this equation for I0. We're going to solve this equation for I3. All right, so take this one down here. I'm going to move the I3 over, the I0 over, and divide by 3. So I have 12 divided by 3 is going to be 4 volts, minus 4 divided by 3 is 4/3. And that'll be I2. And that has to equal I0. All right, then I'm going to do the green equation, and I'm solving for I3, so I'm going to have 5 over 2 minus 2I2 is going to equal I3. Again, just moving the 2I3 over and divided by 2. All right, now that I have these two equations here, I'm going to take them and I'm going to bring them up to my junction rule equation. So I'm going to plug this in for I0, and I'm going to plug this in for I3. And there that is. Now we just have to combine like terms and solve for I2, right? So I'm going to bring the 2I2 over to the other side by adding. I get 3I2. And I'm going to be left with, so I have 8 over 2, which is the 4, plus 5, which is going to be 13 over 2, minus 4/3 I2. Now I have to bring the 4/3 I2 over. That's going to equal 13 over 2. All right, so to combine 3 and 4/3, 3 is 9 over 3, so 9 plus 14 is 13 over 3. Still I2 equals 13 over 2. 13s cancel out, and we get that I2 is equal to 3 over 2, or 1.5 amps. All right, good. Now we've solved for the first one. We have 2 more to go. All right. Now that we solved for I2, we can go back and look at one of our other equations and solve for either I0 or I3. doesn't matter. So we're just putting our 1.5 amps into there and solving for I3. All right, so I'm going to have 5 halves minus 2 times 1.5 amps is equal to I3. So I have 5 over 2 minus 3 equals I over 2. Okay, so we're left with 1 negative. 3 is 6 over 2. So I'm left with negative 1 over 2 is equal to I. That's the I3. All right, so I get that I3 is negative 0.5 amps. And what does that negative mean? All that means is that I chose the wrong direction at the middle. Instead of that current I3 going up on through the 5-volt battery, it's actually going down through the 5-volt battery. So I'll zoom in there at the end because we've got one more step to go, which is solving for I naught. Now, we can go back and just use our junction rule now. So our junction rule is I2 is equal to I naught plus I3. Solve that for I naught, so you have I2 minus I3 is equal to I naught. So we had 1.5 amps minus negative 0.5 amps. Yes, you got to keep that sign. Even though it's wrong, we wrote this junction rule according to the wrong direction of our current. All right, so we have to use that negative sign to solve this out. So we get that the I naught is equal to 2 amps. All right, so let me pull up that picture. Okay, here it is. So what we ended up with is that I naught, which is going this way, is 2 amps. But then it splits, and we have that current going this way of I3 and this one of I2, where we said that I2 was 1.5 amps, and this one, now that it's going in the correct direction, would be 0.5 amps. And that should make sense, okay? 2 amps splitting into a sum of 2, right? So really our junction rule should have been that at the start. But that's the process that you want to take to solve a Kirchhoffs rules or Kirchhoffs rules problem.